All right, guys, so before we get started, are there any questions on the homework? Any questions over the homework assignments before we get started? So what we started with Friday and started on Friday was the quadratic formula, solving these equations, quadratic equations using the quadratic formula. And the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this works for any quadratic equations with real numbers for a, b, and c. Now the first step in solving these quadratics by the quadratic equation is making sure the equation is equal to 0. We have all the terms on the same side. And once we get it on the same side, we're going to find the values of a, b, and c. A is going to be the number in front of x squared, b is the number in front of x, and c is the term that's by itself. So if we look at this equation here, a, b, c, our value of a for this equation would be 1, b would be negative 6, and c is 4.
May I have your attention, please? If you are in the book club, remember that there is a meeting in the library during lunch today. Thank you.
Now, at this point here, what we're going to do is we're going to take those values of a, b, and c and plug them into their corresponding spots in the equation. So we have negative b. Well, our value b is negative 6, so we'd say negative 6, plus or minus the square root of, so b squared, we have negative 6 squared, minus 4 times a, well, a is 1, times c is 4, all over 2a, 2 times 1. So we go and plug these in, we're plugging them in for the values of a, b, and c. A is 1, b is negative 6, and c is 4. Questions on how we plug this in? Now at this point here we need to do some simplifying. So the first thing that we're going to simplify is the negative 6. Well, our negative and negative would make a positive, just telling us that we have 6. On bottom, the denominator, we have 2 times 1. And well, 2 times 1 is just going to be 2. Now we need to calculate what's inside the square root. And at this point here, we can plug, everything that's inside the square root into the 30xs. We can just type it all in as it appears here. Parentheses, negative 6, close parentheses squared, minus 4 times 1 times 4. And that'll tell us that it is 20. Questions on any of this so far? Now, before we can say this is officially done, one, we need to see if the square root of 20 will reduce, if they're perfect square factors. Now, luckily, the 30xs does a good job at simplifying radicals, and it does tell us that the square root of 20 is 2 squared to 5, telling us that x is equal to 6 plus or minus 2 squared to 5 over 2. So we simplified the radical. Now we just need to see if we can simplify the entire fraction. So if the three numbers are 6, 2 squared to 5, and 2 all have a common factor, we need to reduce it out. Now 6, 2, and 2 all have a common factor of 2. And we went through Friday how we would reduce that. And then went through kind of the more simpler way is that we're just going to divide each of these terms by the common factor. So on top, we have 6 divided by 2, which would be 3, plus or minus. Our 2 square roots of 5 divided by 2, we're mainly just dividing that 2 out of the number outside of the radical. And our 2 divided by 2 would be 1, telling us that we have 1 square root of 5. On bottom of this fraction, 2 divided by 2 is 1. Do we need to write a division of 1? No. So it's really just telling us that x is equal to 3 plus or minus the square root of 5. Now, writing the division of 1 is not wrong. We just don't need it. We don't have to write it. Questions on this here? Let's look at the next one. 2x squared plus 4 equals negative 7. Again, the first thing we need to do is get this equation equal to 0. So to get this equation equal to 0, we're going to have to add 7x to both sides. And on the right-hand side, negative 7x plus 7x is 0. On the left-hand side, our 2x squared, positive 7x, and positive 4 are not like terms, so we're just going to write it in standard form. Our standard form is ax squared plus bx plus c. Now looking at this here, what's the value of a? 2. What's the value of b? And c is 4. And all of these would be positive values. Now we know they're positive values because 2x squared, there's not a negative sign in front of it. The 7x is not minus 7x. The 4 is not minus 4. Since there's not a negative or a minus sign in front of any of our values for a, b, and c, all of those are going to be positive. Now we need to start just plugging in the values of a, b, and c into the quadratic equation. So we have negative b. Well, the value of b is positive 7. So we have negative 7 plus or minus the square root of. So b squared would be 7 squared minus 4 times a in our case is 2, times c, which is 4. So inside the radical, we have 7 squared minus 4 times 2 times 4, all over 2a, and a is still 2, so we have 2 times 2. Questions on how we set this up so far? Now we just need to simplify our negative 7. Well, it's just going to reduce to negative 7. On the bottom of the fraction, 2 times 2 is 4. Now we're going to need to simplify what's inside the radical. So our 7 squared minus 4 times 1 times 4. So we can grab the calculator and say parentheses 7. We get to close that parenthesis. 7 squared minus 4 times 1 times 4 is, thank you. It is indeed 2. Telling us that the correct square root, or the correct number inside the radical is 17. Now at this point here, we need to see if we can simplify the square root of 17. And the simplified version of the square root of 17, well, is the square root of 17. It does not reduce, it does not simplify. Telling us that we have x is equal to negative 7 plus or minus the square root of 17 over 4. Now, there is a possibility we could reduce this. We can write it simpler, but that's not going to be the case because negative 7 and 4 do not have a common factor. There's no number that will go into both negative 7 and 4. So this is as simplified as it gets. Even if we had, say, 2 square roots of 17, 2 square roots of 17 and 4 do have a common factor 2, but because all 3 don't have a common factor, it's not going to reduce. No cheat from Friday. Questions on this here? Questions on any of this so far? All right, guys. Let's look at this next one here. 5x squared is equal to x plus 8. Again, the first step is to get the equation equal to 0. How can we get this equation equal to 0? We can subtract 5x squared from both sides. 5x squared and 5x squared will cancel, telling us 0 is equal to negative 5x squared plus x plus 8. Now we need to find the values of a, b, c. A would be negative 5. B would be, and C would be 8. And for this here, the only value that ended up being negative is A. So we have negative B, so that would be negative 1. Plus or minus the square root of 1 squared minus 4. A is negative 5 times C is 8. All over 2 times negative 5. So we plug negative 5 in for A in its 2 spots. We plug positive 1 in for B in its 2 spots. And we plug in the fact that C is 8 in its 1 spot. Now the first thing we're going to simplify is our negative 1, which is, well, just negative 1. We don't have a sign change. It's just going to be negative 1. On bottom, we have 2 times negative 5, which would be negative 10. What is the likelihood that we're going to have a common factor that's going to simplify on top and bottom? Probably not, because negative 1 and 10 do not have a common factor other than 1, so that's not going to reduce. Now the next thing we need to do is type everything inside that radical into the calculator. So we're going to do 1 squared minus 4 times negative 5 times 8. Mm-hmm. One squared minus 4 times negative 5 times 8 tells us it's 161. Now at this point here, we do need to make sure that 161 does not, radical does not reduce. The square root of 161 is, well, the square root of 161. So it's telling us that we have negative 1 plus or minus the square root of 161 over negative 10. Questions on how we got here? Now the one thing we don't want to leave is a negative. I do not like leaving a negative in the bottom of the fraction. So what we can do is we can factor it out of the denominator and multiply it back through the numerator, just so we don't have a negative on the bottom of the fraction. So really what we're doing is we're factoring negative 1 out of the denominator, which is going to make it positive 10. But we have to take that negative and multiply it through the numerator. So our negative 1 is going to become positive 1. Because really what we just did is we multiplied negative 1 by negative 1. The negative and negative make a positive. Our 1 times 1 is still 1. Now this is something interesting with plus and minus, because we're going to multiply that square root of 161 by negative 1. So we have the positive and negative. So when we multiply a positive by a negative, it's going to become negative, because our plus, when multiplied by negative 1, is going to become a minus. And our negative, that minus, when multiplied by a negative and negative make a positive. So the plus and minus becomes plus and minus. So really, the positive became negative, the negative became positive, so it's still plus and minus. And that's it. So really, when we take that negative out of the bottom of the fraction, all it does is turns that first one, that negative b, into positive b. Or if it was, so that negative 1 became positive 1. If it had already been positive 1, it would switch it back to negative. Questions on this here? All right, guys, let's save that for later. Questions on this here? Questions on anything we've done so far? We ready for the next one? (25x² minus 8x equals 12x minus 4). Again, we need to get this equation equal to 0. Now, up to this point, all we've had to do is move a single term over, and we're good. Here, we're going to need to move 2. We can either move the 25x² and -8, or we can move the 12x and -4. What do we want to move first? 12x. And we can do that by subtracting 12x from both sides. Now, the 12x minus 12x is indeed 0, leaving us with -4 on the right-hand side. Now, on the left-hand side, our -8 and -12x, or -8 minus 12x, those are like terms, so we're going to have to combine them. -8 minus 12 is going to be -20x. Then we can add 4 to both sides, telling us that we have 25x² minus 20x plus 4 is equal to 0. A, B, C. A is 25. B is -20, and C is 4. So we have negative B, so that'd be -20, plus or minus the square root of -20² minus 4 times A is 25, times B, which is, or C, which is 4, all over 2A, 2 times 25. So we plug B into its 2 spots, plug -20 into the 2 spots for B, plug 25 in the 2 spots for A, and 4 in the 2 spots for 4. Now our -20, the negative and negative make a positive, giving us +20. On bottom, we have 2 times 25, which would be 50. Well, we can see there's a good chance something is going to reduce, because 20 and 50 do have a common factor of 10. So something might reduce there. Inside the radical, we have 20² minus 4 times 25 times 4. Well, up to this point, we've been plugging them in, typing the whole thing in, and then typing it into the radical. Well, and it's always been that, like on the last one, we got 161 and then just put it in the square root, so why not just do the whole thing all at once? And it works. It tells us that it is 0. The only issue we ever have with trying to type the whole thing in, switch this to a 5, is if that's negative. It tells us it's a domain error, so we have to clear it out. All the way back here, delete it. Okay, it's -100. So the negative is going to come out as I. I take the square root of 100, telling me that it's 10i. We have to do a few extra steps. So it tells me that really -20² minus 4 times 25 times 4 is going to be 0, even though we did it with is indeed 0. Now the square root of 0, because we're saying what times itself is 0, well, that is just 0. So we have 20 plus or minus 0 over 50. Can we add and subtract 20 and 0? Well, yes, they're like terms. So what that's telling us is that we have x is equal to 20 plus 0 over 50. And we also have x is equal to 20 minus 0 over 50. Well, 20 plus 0 is 20. And 20 divided by 50 is 2/5. Or really, we could plug it in the calculator. 20 plus 0 over 50, enter. It'll reduce it to 2/5. Now 20 minus 0 is still just 20. And 20 divided by 2/5 is 2/5. So we're saying that x is equal to 2/5 and x is equal to 2/5. So the solution for this is 2/5. We do have it twice, so we still have two solutions. They're just not unique solutions. They're not different values. Because we can have the same value twice. Questions on this here? Are you ready for the last one of these that we're going to do? There's one other thing we're going to look at, but we're going to look at one more of these here. X squared plus 4x equals 13. Negative x squared plus 4x minus 13 is equal to 0, because again, we just got to get it equal to 0. Now the nice thing with the quadratic formula, as we've seen up to this point so far, is that the value of a really doesn't matter for this here. For completing the square, a had to be positive 1. For factoring, it worked best if a was positive. Here, a being positive or negative makes no difference on how we solve this. The main thing is that we need the equation equal to 0. So we start plugging it in, negative b, so we'd have negative, and we're going to replace b with 4. Inside the radical, b squared, so we're going to have 4 squared. Minus 4 times a, well, a is negative 1, and c is negative 13. All over 2 times a, 2 times negative 1. Now at this point here, like most of the problems we've had so far, our negative 4 is going to be, well, negative 4. The denominator 2 times negative 1 is going to be negative 2. Inside the radical, we have 4 squared minus 4 times negative 1 times negative 13. 4 squared minus 4 times negative 1 times negative 13 is negative 36. Now this one here, the negative 36, if we want to see if it reduces, we can't just plug it straight into the 30xs, the yellow calculator, because it cannot take the square root of a negative. But we do know that that negative is going to come out as I. And what we have left over with this square root, after we take the negative out as I, is really just the square root of 36, which is indeed 6. Square root of 36 is 6, telling us that the square root of negative 36 would be 6i. Questions on this here? Now we do need to divide everything by the common factor, because there is a common factor. And that common factor we're dividing out is what? 2. And we can take the negative with it. Because the denominator, if I divide it by negative 2, it'll tell me that the denominator is 1. We're taking that negative out and the 2 out. We want to get rid of both. On top, negative 4 divided by negative 2. Well, the negative and negative make a positive. 4 divided by 2 is 2. Now, 6 divided by 2, or 6i divided by 2, is going to be 3i. Because if we just divided it by 2, the 6i would become 3i. Now, since we divided by negative 2, the plus or minus, the positive, the plus of this is going to become negative, and the negative is going to become plus. So really when we divide the plus and minus by a negative, or we apply a negative to it, the plus becomes minus, the minus becomes plus. We still just get the plus or minus, telling us that x is equal to 2 plus or minus 3i. So did really what's inside the radical change? Or what's inside the radical being negative really change much on how we do this? No, it just changed kind of the steps or how we approached it with simplifying. But really, if we simplify what's inside the radical first, then take the square root of it, it actually flows quite nice, quite well. Any questions on this here? The last thing we have is talking about the discriminant. The discriminant is our b squared minus 4ac. That is what we call the discriminant. Now the discriminant can have one of three values, three types of values. Is that it could be greater than 0, it could be a positive number, it could be equal to 0, or it can be less than 0. Because if b squared minus 4ac is greater than 0, we're going to have two real solutions. Because we're going to have a number coming out of that radical, positive number. So we have a positive, negative version of that number. It will give us two solutions. As we've seen already today, if it is equal to 0, we have exactly one real solution. I would say one unique solution. We still have two solutions, it's just that they're both the same number, as we saw with 2/5 and 2/5. Or I'd say one real solution. And if it's less than 0, it's going to call it imaginary. I call it complex. We'll have two complex solutions, as we just saw in the last one. So if e squared minus 4ac is greater than 0, we have two real solutions. If it's equal to 0, we have one real solution. If it's less than 0, we have two complex solutions. Now, when doing these here, especially with the discriminant, we do need the equation equal to 0 still. Now, as we look at the first one, x squared minus 6x plus 10. It is already equal to 0. So let's see what a, b, and c are. A is the number in front of x squared, in this case is 1. B would be -6, and c is 10. Now for these here, it's wanting us to find the discriminant, describe the number and type of solutions. So we're looking at b squared minus 4ac. Well, b for us is -6 squared minus 4 times a times c. So we have -6 squared minus 4 times 1 times 10. -6 times minus 4 times 1 times 10. And again, at this point, I would just grab a calculator. -6 squared minus 4 times 1 times 10. And it tells us that its value is -4. So we found the value of the discriminant is -4. Now is -4 greater than 0, equal to 0, or less than 0? Less than 0, so it tells me what I have. That's it. The book takes it a step further, saying that it actually wants us to solve it. But this is as far as I want to go, because it asked us to find the discriminant's value, the number and type of solutions. The discriminant's value is -4. The number of solutions we have is 2, and their type is complex. 2 complex solutions. Questions on how we got to this here? Now, if we wanted to solve it and finish finding the values, well, x is equal to what? -b, so -6. Plus or minus what? The square root of b squared minus 4ac, which is -4. All over 2a, well, that'd be 2 times 1. So really finding the value of the discriminant kind of got us most of the way there. Negative negative 6 is 6. 2 times 1 is 2. Negative square root of negative 4 is going to be 2i. We can simplify it by dividing everything by 2, telling us x is equal to 3 plus or minus 2i. But for this part of the homework, all I'm looking for is the value of the discriminant, number and type of solutions. Let's look at B. A, B, C. A is still 1, B is negative 6, and C is now 9. Now, if we type it into our B squared minus 4AC, this time we get negative 6 squared minus 4 times 1 times 9. Which is 0. So the value of the discriminant for this quadratic is 0. So since it's equal to 0, we have what? One real solution. And that's it. Really, we could say one real unique solution. There's still two solutions. They're just the same value. Because with quadratics, we will always have two solutions. It might be that both values are the same. They might be both different, but we will always have two. Let's look at this next one. We have x squared minus 6x plus 8 equals 0. Well, A is, B is, and C is 8. Four. Negative 6 squared minus 4 times 1 times 8 is going to be 4. Since the discriminant is greater than 0, we have two real solutions. So our value of the discriminant is 4. We have two real solutions. Questions on this here? Do we feel comfortable finding the discriminant's value and determining the number and type of solutions? Because even if we had fractions, like number 8, A would be 1/2, B would be 1, C is negative 1. So B squared minus 4AC would be 1 squared minus 4 times 1/2 times negative 1. Squared minus 4 parentheses negative 1. Is 3, so we have two. That's it. Questions on this here? 4. I think number 7 technically is going to be 0, one unique solution, because we're looking at 8 squared, which is 64, minus 4 times 4 times 4, which is 4 cubed. Actually, it should be negative. I'm thinking about it. Let's see here. Let's just check. 8 squared minus 4 times 4 times 4. Oh, it is 0. Yeah, because 4 times 4 is 16. 16 times 4 is 64. 0, one unique or one real solution. Will you feel comfortable with these here? Because even these here, all we got to do is get the equation equal to 0, plug the values of b, a, and c into the discriminant, and simplify. Not going to worry about that. That is it. The homework for 3.6 is problem 6 through 16 even, 21 through 24. 6 through 16 even, you're given a quadratic equation you need to find. You need to solve it using the quadratic equation. 21 through 24, given the quadratic, find the value of the discriminant, the number and type of solutions. So you're going to find out what the value of b squared minus 4ac is, and then determine if it's 2 real solutions, 1 real solution, or 2 complex solutions. So really the number of solutions is either going to be 2 or 1 unique. And then we either have real solutions or complex solutions, one or the other. And that is it for chapter 3. We're done with chapter 3.